Welcome back. Today's lesson is on the chain rule in calculus. So, what is the chain rule? When do we do it? Well, it's when you need to do the derivative of a problem where you've got a function. See if I can do this. You've got a function inside of a function is what we've got in this problem. So you've got the derivative of a function inside of a function. So how in the world do you do a problem where there's two functions in it? I can do basic power rule derivative, but how do we do this? Well, it's not that much hard. All you've got to do is go back and you take the derivative of the outside function. Take the derivative of the outside, and then all you've got to do is multiply that by the derivative of the inside. So you take the derivative of the whole thing and times it by the derivative of the inside. Now, if you don't like this notation, you might like this function of u notation. So once again, though, it still stands the same. We're going to take the derivative of the entire function and then multiply it by the derivative of the inside. And so let's go ahead and just do some examples. In calculus, that's the best thing you can do. You can write equations all day long. Now, I've got my first example here, and what's funny is I don't know particularly that I like it, but we'll see if we can do it. Let's see what we can do here. I'm going to go to red. And so first off, I want to do something. This radical of x squared plus 1, that's if you've done any derivatives so far, that's kind of could be a little confusing right there. So what I'm going to actually do is this. I'm going to change this to x squared plus 1 to the 1/2 power. And now makes a little bit more sense to sit here and look at it. Now, here's what I need you to recognize. You've got two functions in this problem. The x squared plus 1 is a function all of its own. And then what you've also got is this x squared plus 1 to the 1/2 power. Well, that's a function of its own too. So once again, we've got a function of a function. So so we need to take the derivative of the whole function. So this blue thing, we're going to take the derivative of the whole thing, and then we're going to multiply it by the derivative of the inside. Now, just for the sake of doing this, let's do something. Let's do a little substitution. Let's slip over here to the side, and let's say that u is equal to x squared plus 1. And now let's come over here and just replace the inside of this with u to the 1/2 power. Now that's something you should be able to take a derivative of very easily. So all I'm going to do is do the power rule on this. So what's the power rule? Times by 1/2. So this would be 1/2 times u. And then after you times by your exponent, what are you going to do? Subtract 1 from it. Well, 1/2 minus 1 is negative 1/2. And now you might be looking at this thinking, geez, we've pretty well got this knocked out. Well, we kind of almost do. You just got to remember something. To do it, we've got to take the derivative of the whole thing times the derivative of the inside. So if we go back to up here, take the derivative of the whole thing times the derivative of the inside. Well, what's the derivative of the inside? Well, the derivative of u prime would be, and just do a power rule on this, x squared would be 2x plus the derivative of 1 is 0, which means there's no point in writing it. So now I'm going to multiply that by u prime. So I'm going to multiply by u prime at this point. And I'm going to erase that u prime out of the way and just put what I'm going to multiply by. I'm going to multiply by 2x. So now what happens when we multiply this together? Well, if we go to multiply, we end up with 2x over 2 times. Now, instead of writing out u, I'm going to write what u is supposed to be. This was just to help you learn how to do it. You're not going to do this substitution all the time. So instead of u, I'm going to write x squared plus 1. And bam! Theoretically, I'm done. Although that answer would probably get you in trouble with a teacher. because it's kind of ugly. So let's see if we can't clean that up a little. How can we clean this up? Well, let's see. Well, 2 divided by 2 means that's gone. So that's kind of reduced it to x times x squared plus 1 to the negative half. But the thing is, math teachers usually don't want you to have like this negative 1/2 power here, but we can fix that too. So we can change that to say x over x squared plus 1 to the half. Or your teacher may want you to put the radical back in. I don't care. I'm a physics teacher, so this will work for me over here. But anyway, we could rewrite that as the radical of x squared plus 1. So in this problem, we've got y prime is equal to one of these two answers. Wow, I'm writing pretty sloppy right now. Woo, now that might be a little harder because of that radical. Let's go down and do this next one. It'll be a little easier. And we're going to work it the way we'd normally work it. So once again, if we go to work this problem, we've got this 3x plus 2. That guy's a function. And then this entire thing is also a function. So multiply by, so take the function, take the derivative of the entire thing. Well, that would be 5 times 3x plus 2. And now, we multiply by 5, and then we subtract 1 from it. So take the power rule. Times by 5, subtract 1. So that'd be 4. Now, times that by the derivative of the inside. So what is the derivative of 3x plus 2? Well, that would be 3 and 0. So times 3. So look at how clean this answer is and how quick it is. 15 times 3x plus 2 to the 4th. So bam, there is my derivative in this problem. Oh, wow, that was not too bad at all. What if you were wanting to do a second derivative in this problem? Let's say your teacher is really insane and they're like, okay, great, now go y prime prime. What would be the second derivative? It's no big deal. You do the power rule again. You just look at it. You've got this big outside function, and then you've got this inside function. Well, you do your power rule. 4 times 15. 4 times 15 would be 60 times 3x plus 2. And then we subtract 1 from 4. So that's to the 3rd power. And then we times by the derivative of the inside, which is 3x plus 2, which is 3 again. So now that answer would be 180 3x plus 2 to the 3rd. So there's our second derivative. Could we take a third derivative? Yeah, we'd do the same thing again. Multiply by 3, subtract 1 from it, multiply the derivative of the inside, which is still just 3. It would be the derivative of the inside. That's it. At this point, you might not even want to watch the rest of the video. You might have this down, but I'm going to do a couple more examples just to see what you can do. So here, we'll do the same thing again on this next one. Let's see what we got. Take the derivative. You've got this inside function, x squared plus 1. And then we've got this big outside function of x squared plus 1 to the 3rd. So we're going to take the derivative of the entire thing. Well, that would be 3 times x squared plus 1. Subtract 1 from the 3. So that's going to be 2. Times the derivative of the inside. What's the derivative of x squared plus 1? Well, x squared plus 1 would be 2x 0. So it's just 2. So my answer is 6 times x squared plus 1 to the 2. And so there is my answer, y prime. Hey, I got this. Well, I'm going to keep doing some examples. You can quit if you want. I'm going to keep going. I got 3 more here. Once again, what do you do on this problem where you got this radical? You want to take a derivative. Get rid of the radical. Don't write that radical. Thing's ugly looking. Just rewrite it as 3 x squared minus x plus 1 to the 1/2. So now do your power rule. Times by half and subtract 1. So that would be 1/2 times 3x squared minus x plus 1. Subtract 1 from 1/2. That'd be negative 1/2. Which means when we write our final answer, we're going to need to put this on the bottom when we do it. Now that we've took the derivative of the whole thing, now let's take the derivative of the inside. So what's the derivative of, what are we taking the derivative of here? 3x squared minus x plus 1. What's the derivative of that? That would be 6x minus 1. Appears that's all we've got, isn't it? 6x minus 1. Yep, because plus 1, yeah, that's 0. So there's what we've got. Now, that would be a horrible, ugly answer. So we need to see what we can do here. Well, let's see. We're going to times that by half over here. So we end up with 3x minus 1/2. And then let's do this. Over 3x squared minus x plus 1 to the 1/2. Ugh. Hey, I never said it's going to be beautiful, but the reality is if somebody gave you a value of x, you could substitute it into this and get an answer now, which is all that we're after at this point. What about this guy, cube root of x squared? Ooh, what in the world is this? And this one looks like it's going to be horrible. It looks like a function of a function of a function. Actually, no, it's not. If you're thinking this was like a triple chain rule question, it's really not a triple chain rule, although somebody might try and do that. Really what you've got to do is this one is rewrite it because of the radical. So you've got x squared minus 1 square. Oh, that's a horrible looking little square I made, ain't it? So let's go back and try that again. Square. And now, here's what I'm going to do. I'm going to put this to the 1/3 power in this question. Well, right off, it looks like this is going to be a function of a function of a function. And reality is we could work it that way. We could work it as like a triple chain rule. But I'm just going to go back and write x squared minus 1 to the 2/3. I'm not going to try and work it as a function of a function of a function question. It's a little bit easier than that. I'm just going to take a third root of this square. So be to the 2/3. And now all we got to do is now we've got basic chain rule. Times by 2/3 times x squared minus 1. 2/3 minus 1 is negative 1/3. Times the derivative of the inside, which would be the derivative of x squared minus 1 is just 2x. So we end up, let's see if, wow, if I run out of room on this, haven't I? So let's see, we're going to end up with 4x over 3 times x squared minus 1 to the 3rd power. And there's going to be our answer. Good grief. Let's see this one last one. I'm feeling pretty confident in what you've been able to do here. So let's do this one. And this problem is easy. It's just got something going on here. I'm going to rewrite that as x to the negative 5 plus 2x squared plus 1 to the 4th. Just remember that this x to the negative 5 hasn't got anything to do with this over here. This is, we've got a plain old derivative and a chain rule in the same question. So we're going to come back and we're going to take a derivative of this guy, and then we're going to split this one up into 2 parts though. Because this guy over here, we've got to do a chain rule on. So this one's going to be our chain rule over here. But this guy on the left, he's going to be easy. He's going to be negative 5x. Now this is going to be negative 5 minus 1 is negative 6. Then we've got over here plus The derivative of this entire thing is 4 times 2x squared plus 1. Subtract 1, leaves you with 3. Don't forget, it's a chain rule. So you got times by the derivative of the inside. Well, the derivative of 2x squared plus 1 would just be 4x. I'm going to times by the derivative inside. So now that's kind of turned this into 16x times 2x squared plus 1 to the third. And don't forget, we had this over here, which I don't really like that, so I'm going to rewrite that as negative 5 over x6. And so here, and I guess if we started with a g of x, then I need to write g prime of x is equal to that. So the chain rule is actually here to kind of make your life a little bit easier as all it is that you're doing. And the hardest thing is for y'all is just to recognize if it is a chain rule. And the first thing I do is just look for the first problems in homework usually look like this, where you've got a radical of a function or you've got a function raised to a power. And just remember, you take the derivative of the entire function and multiply it by the derivative of the inside function. All right, that should get you started on some homework. So thank you and have a great day.